Hello. Can you hear me well at the back? Okay. This side as well? Cool. Welcome to Dispelling Python. To Dispelling Python's Magic. My name is Tomek Paczkowski. I work for a small company called Squirrel in London. And today we're going to re-implement PyTest in 100 lines of code or less. So first, some warnings. This presentation is very code-heavy, but the code itself is not hard to follow, so you should be all right. Also, all examples here work on Python 3.4 and later, but not earlier. All right, so let's start. First of all, what is PyTest? PyTest is a testing framework that's very Pythonic in nature. What do I mean by saying Pythonic? It includes test discovery, so you don't have to build your test suite by spelling all those test names and stuff. But that's pretty popular nowadays. It has no boilerplate, so you don't have to import any classes. You don't have to know names of methods to use. It has awesome plugins like plugin for coverage, plugin for running tests in distributed manner. But most importantly, it allows you to use assert statement for testing. Normally, in Python, assertion statements are kind of boring. If you don't produce your own message, it just says it failed. That's it. Well, PyTest changes it. Let's see how. Let's consider this, this function. It's very complicated, so you can probably spot all the bugs there. But the buggy part is actually test. So, well, that's how you write tests in PyTest. You start a function with test underscore something, and that's pretty much it. Later on, in your test, you write assert something something. In our case, we'll be asserting that double of 2 is 5, which is not true. It serves a purpose. When you run this code on PyTest, you will get something like that. It shows you how the offending function looks like. Most importantly, it tells you the intermediate values that were used for assertion. You can see that 4 equals 5. That's pretty much not true, and you're immediately better because you're not looking at assertion failed, and that's it. So PyTest has a reputation of being kind of magical, and I was trying to figure out how I could replicate this. Well, I'm not MacGyver, so first thing I did, I was Google search for PyTest assertions, and I found an interesting article by a person who wrote the changes that are now present in current version of PyTest. The chap is called Benjamin Patterson. His article is called Behind the Scenes of PyTest New Assertion Rewriting. At the bottom of the page, you can see a link that will lead you to this article. You can read it yourself. It's a little bit outdated. Python moved on a little bit. The APIs got better. So cool. Yeah, I was happy to find this article because that meant I didn't have to think for myself. After reading that, I had a game plan ready for how to re-implement PyTest. Nice and easy. My grand plan starts with importing this module, AST. AST stands for Abstract Syntax Tree, and generally this is a data structure used to represent past source code of your program in form of a tree, which means that it's past all those text limitations, so you don't have to worry about encodings, new lines, blank spaces, order of operators, and so on, which makes it really nice for kind of inspecting the code and possibly modifying it. Let's learn a little bit more about those abstract syntax trees. Let's consider our assert statement, because that's what we are ultimately interested in. The conceptual decomposition of this statement into syntax tree nodes will look something like that. We will have assert node at the top of the tree, actually at the bottom because it's root. The assert statement links to another node, which is assertion test. In our case, it's equality comparison. Now, equality comparison in this case has left-hand side and right-hand side. Left-hand side is a function call, and function call is a node that consists of, in this case, function name, or the function part of it, which here is a variable. It's called double. And we have arguments. In our case, the arguments are just a constant, number 2. All right, that finishes the left-hand side. The right-hand side of the comparison is, again, a variable, in our case, expected. OK? Not that hard. So let's see what Python thinks about this. In AST module, there's a parse function. You can read about it at the documentation, link at the bottom. If you run ast.parse on string of code or bytes with code, it will give you whatever Python thinks your code is, or what the abstract syntax tree for this code is. Okay? So let's start. By the way, in this short example here, all classes come from AST module, but I kind of didn't include the import statement here for readability. So, as shown in the diagram, we'll have our root to be a set node. Our assert node has one field, and that field is test. This test is a node. It's a comparison node. A comparison node is common for all Python comparisons, so equals, not equals, less than, greater than or equals, stuff like that. Compare node has three parameters, 3 fields. Left-hand side of the comparison, the operator, and the right-hand side. Of course, Python is a little bit more complicated in that you can have comparisons of more than 2 values. So, for example, A less than B less than C. This is valid Python code. So, in this case, compare operators and comparators are lists. So, we have multiple right-hand sides. In our case, we're going for a simple one right-hand side, but it's still a list, one element. Okay. Our left-hand side is a call. It has a function node and arguments nodes, which is list. In our case, function node consists of one node, which is name, and the ID of the name is double our variable. Arguments, number, the constant number of 2. Right-hand side is, again, a variable. This time it's expected. This is the whole code. The Python's documentation for AST module is not the greatest. I don't think it was designed for people to reuse, but someone thought it's nice to fill the gaps in this, and there's a page called Green Tree Snakes, and you'll get there if you follow the link at the bottom of this slide. Okay, so knowing the abstract syntax trees, I've identified the first goal of my little project of rewriting PyTest. And this goal is to modify an assertion statement to call a function with both sides of the comparison. Okay, that doesn't sound like PyTest, right? But I only have 25 minutes to finish this talk, so bear with me. What I mean by this modification is that we will take code that looks like that and modify it into something like this function code. The function will have intermediate values, what's the double of 2 and what's the value of expected, and we will be able to use those values to produce a helpful message. Okay, so how do you go and modify a tree? Well, we're not alone there. The AST module does allow us to do this to some degree. It exposes a class called Node Transformer, and it's good for inspecting and modifying trees. It implements visitor pattern, which means that this class will call a function called visit_class name for each node it traverses, where the class name bit is the name of node that we're inspecting. It's a mouthful, so let's see the code. It speaks way better than me. We start by, okay. There's some more code, but it's the contrast is too low. So let's figure out how do this work. All right. We start with inheriting from node transformer. We have our new class. We define a method called visit assert. Assert is capital because that's the name of the class. The node as a first parameter is the node that we're visiting, so it will always be assert node, so that's good. First thing we need to do here is to build the node for function call, so that's what we're doing. We have our function arguments and keyword arguments. Keyword arguments, we're not interested in that, we're not doing this. Function node is name assert equals. The load there is significant is there just to say that we're loading variable and not storing it. Okay, and the arguments for this function are left-hand side of our assert test node and right-hand side of our assert test node. Next, in Python, the syntax says that if you have a lone function call on in the line, that's an expression, so we need to kind of wrap it in an expression node and do some bookkeeping to keep that to say that this call happened exactly at the line where the assertion statement was. All right, and that's the complete code, and you can see everything. All right. Some of you might wonder where this, we create a call to function called assert equals. Where is this function coming from? We don't want to force users to kind of import this function for themselves in each test module they use, right? So we need to create something that will help us. Basically, what we need to do is to make this import for users ourselves. We can do this. It's actually easier to do it outside of the node transformer, so I implemented this as a pure function here. So the function will be called transform, and it will take module argument here. Module argument is the root of syntax tree for module that we're modifying. So it's a node. First thing we do, we create this import statement that we want. It will be in the form of from test utils import something. We say that it's on line 0, column 0, because we don't actually want to show it to the user anyway. And from our test utils, we will import assert equals. The node there is part of the syntax saying from something import my test function as. We don't want the alias part, so we just say none. Okay. Now we inject our import node into the module's body at the beginning, so it's there. Now, just to keep everything together, we run our node transformer that we created in the previous slide all together, and it's done. That's the complete code. I'm glad that I included this. Now, there is a little problem here. If we inject this import, and then later on, user goes on and defines a function called assert equals, and in this assert equals, user will use assert statement, we'll get into trouble, the kind of infinite recursion type of trouble. So we need to modify this to kind of name this function in a way that's less problematic, all right? Fortunately, we are outside of Python's lexical context, so we're free of text limitation. So we can actually name our function, we can alias our function as #eq. So in the code, this statement would be from test utils import assert equals as #eq. #eq being a comment in the code. Well, there's not much chance that we are actually going to clash with something here, all right? Of course, we need to go back to our node transformer and change our function call to use the new name for assertion, right? So EQ. Good. That concludes our first goal. We have something that can transform a module, assert statements in a module into function calls. Cool. So the second part is Python's import system. It's mostly handled by the things we will be working are mostly in the sys module, so that's what we will be working with. The most helpful things that we'll be using is import path hooks. I know there was a talk yesterday about Python's importing system. I wasn't able to attend that, so hopefully those of you who weren't there will get something out of this, and my explanations will not go in vain. So Python exposes import hooks so that to allow you to extend its import system to do all kinds of weird stuff like importing files from zip archives or even from URLs or maybe from database if you like to live dangerously. What are import hooks? They are functions that live, or callables that live in this list, sys.path_hooks. Those hooks work on individual entries in sys.path. So for each path, for each entry in sys.path, your import hook will be called, and you will be able to tell, okay, I'm interested in handling this path or not. The function needs to return, the callable needs to return a finder, and what it is, I will explain in a minute. And there's also something called path importer cache, which basically caches the result of import hooks. So if you modify import hooks, you probably need to clear the cache. Okay. There's very good documentation in Python, in Python standard documentation on the importing and dealing with import hooks, so I advise you to read it. Now that we know something about how the import works, we can state the second goal, which is to write an import hook that will use something that we've written before to modify imported code. So we now have we'll be able to modify modules as they're being imported. Okay, so as I said, import hook is a function that works on individual entries of the sys.path. Those entries they're various, but for our purposes, we're only interested practically in code that's in the current directory, so our application code, right? So we will check that the path that we are given is this current directory. That's a little quirk in an import system that you need to check for absolute path. We're interested in only this, and if this matches, we return a finder. What is finder? We'll learn in a minute. If we're not interested in this path, we raise import error, and everything goes back to normal. We let Python handle that as usual. Last thing, we need to install the import hook. We insert it into path_hooks, and we clear the cache. That's the complete code. Okay, so I promised to explain what are finders. Actually, they are very simple. They're very simple interfaces. They need to only specify one method called find_spec. And this function should return something called module spec. Module spec is import system representation of something that will become a module. And its attributes translate directly into whatever will end up in modules __ attributes. So __ file, __ name, __ path, and so on. So let's implement this finder. Okay, we start with class. We define the required function. The function takes 2 arguments. Target, we're not interested in that. It's a little bit of a corner case. We're not dealing with corner case here. Module will be a string with fully qualified name to our module that is being imported. Okay, so if module is name of the module imported, then the file name will be, of course, module plus .py. Easy. Finder needs to say that the module does not exist and it's not importable. So we check that this file name exists. If it doesn't exist, we return none. Python will then rise import error in our code, and we'll know that we did something wrong. Now we know that the file actually exists, so we return module spec using a helpful function from importlib called spec from file location, giving it a name, which is the fully qualified name of this module, location, our name plus py, and the loader. What is loader? In a minute. That's the whole code. So those of you who are still not asleep will maybe notice that this will only work with top-level modules, because if you have any package, then it's not as simple as adding your name plus py. You need to add slash underscore underscore init py. It's a corner case. We're not dealing with that. So loader. Again, it's a very simple interface that we need to implement here. Only one method called exec module. This time, it has slightly more responsibilities. It needs to execute module code, or that's supposedly, and it should populate module namespace. Okay, easy enough. Let's implement that. So class loader, our function exec module. Here, the module parameter is no longer a string with name. It's an actual module instance with all of the attributes from module spec we return in Finder copied into this module instance. So it will have underscore underscore name underscore path and so on. But it's still empty. There's no code has been executed in this module. First thing we do is we read the source code from the file. We know this file exists because we checked this in Finder, so no error checking needed. Next thing, we use the parse method to parse this code. We actually read bytes and not Unicode string. And we let the parse method to actually detect the encoding of the bytes and handle all those quirks. Basically, what happens if you change the encoding and have an encoding statement at the beginning of a file. So now we have the tree. We use the function we've written long ago to transform this tree, inject import statement, replace assertions. And then we compile this. With compile is built-in function, and execute this, again, built-in function. Worth noting that we execute this with globals set to module dot underscore underscore dict, which is the module global namespace. Okay, complete code looks like that. Those of you who still are following will note that we're not handling PYC files in any manner. Corner case. As a bonus, we're modifying module namespace, so we can actually directly inject our function without this import hack that we did there. So we can actually shave 2 lines of code from our previously written code. Again, we're not limited by Python lexical rules, so we can still call it hash EQ. Okay, and the step 3 to re-implement PyTest is to implement test discovery. That would be pretty much it. But we don't have time for that. That's actually very complicated. Not really, but the way the PyTest does it, it's actually very smart. Let's assume that this is enough for test discovery for today and for a 25 minutes talk. Hey, demo. Okay. Let me just bring. A little bit too much. So this is the full module as described in this talk. Some imports, our import hook, finder, pretty much the same, loader, node transformer, our transform function with shaped off lines, our assert equals function. And because I had time at home, I actually did write a very simple test discovery. As you can see, it's 10 lines of code. And this is what happens if we run the code in this module. We insert, so we install our import hook, and we go through all names in program arguments, and we run the test discovery on those modules. Okay. Doesn't look bad. Confusing order of. As you can see, in this file, in this directory, we have our testing module called Dispel, and we have sample test, which has a couple of tests. And now, if I run this, we get errors, and most importantly, we have our assertion statement and some immediate values. Right? That's it for the demo. Summary. This is probably something that you shouldn't be doing every day. You should be really thinking hard about this, because it's very easy to shoot yourself in the foot with a giant cannon that this is. Corner cases left for the reader. And by corner cases, I mean all the work. There's multiple instances where I've said this is not there. Biggest being ignoring all the imports qualities that we are happy to have in Python, like PYC files that are cached. PyTest does this. Namespace packages, PyTest has support for that, and so on and so on. So there's lots of stuff to do. On the other hand, we were limited to 100 lines of code. On the other hand, Python is awesome. It only takes 100 lines of code to write your own PyTest. All right, that's the end of the presentation. You can, it's actually published already. You can find it under this URL. You can find the code I've shown here under github/oinopion dispel. Thank you very much. My name is Tomek Paczkowski. You can find me as Oinopion on the internets.